2011 problem 1. I'm going to level with you guys. This might be the worst problem that we've done in terms of AP review. Especially parts E and F just turn into an absolute algebraic mess. I think it completely loses the physics and it turns into a very weird algebra problem. However, there is a key word that we have to pick up on here, and it's the word derive, so that's why this video is probably going to be a little longer than the other ones. That word is critical if you are solving a free response problem, and it's something that I learned about when I was an AP reader for the first time last year. So this problem actually starts out kind of okay, I think a little too many variables, but what we have here is we have a projectile being launched from a device. They tell us that it gives an initial impulse, JP. We remind ourselves that JP is the change of momentum. We also know that the change of momentum is equal to F times delta T. So they're going to ask us for a lot of information. In parts A and B, they use the term determine. So determine an expression for the time required for the projectile to travel the length of the launching device. You need to recognize the relationship between impulse and F delta T. Delta T representing the length of time that the object is inside the device, because they tell us that it experiences a force average. So they tell us that the impulse is something that we know. They tell us that the force average is something that we know. So we can solve for delta T how long the object was in the chamber. Again, I don't like this problem because I think it's giving you way too many variables. Part B is also pretty okay. They now ask us to determine an expression for the mass of the projectile. Well, JP is equal to the change in momentum. We remind ourselves that momentum is m times v, and since the initial momentum was 0, that means that the final momentum is m times vx, one of the given quantities, so vx is equal to jp over m. Okay, this word derive is critical when you are doing a free response problem. That means you need to start with a fundamental physics equation. In this case, for deriving an expression for the work done in stopping the projectile, the fundamental physics equation that we need is work is equal to delta KE. Work is equal to the change in kinetic energy. I got news for you. If you don't include that, and you immediately go down here to KE final minus KE initial, or, God forbid, you go down here to work is equal to minus 1/2 mvx squared, you will be awarded 0 points on this problem. Whenever you see, y'all listening to me? Whenever we see the word derive, we need to start out with a fundamental physics equation, otherwise you risk getting no points. I did not learn about this until I was an AP reader. So, in part C, derive an expression for the work done in stopping the projectile. We know that work is equal to the change in kinetic energy, so that's our derivation starting point. KE final minus KE initial. We know that the initial velocity is going to be Vx. The final velocity is going to be 0, so notice that the work is equal to minus 1/2 mvx squared because we're dealing with that initial term. If you don't put that minus sign, you're going to lose a point. Now here's where the problem starts getting obnoxious, and I really don't like it. We don't know the mass of the object. So they are expecting us to do a replacement from back over here of Vx equals Jp over m, and they're expecting us to solve for m as Jp over Vx, and substituting that in here for m. Guys, I just think that's freaking ridiculous, honestly. Like, this really pisses me off. I don't have any time for that. I think this problem was made by a very cranky physics professor. I don't know why they're doing that. You guys haven't seen them pull any kind of crap like that, and all of a sudden on this problem they're asking us to do that. I think if we had just stopped here, that would be a good problem, but the fact that you don't know the mass of the projectile is just obnoxious. But whatever, we do the substitution, Vx in the denominator cancels out one of the Vx's in the numerator, and we get minus 1/2 JpVx. Dramatic pause. Now once again, we have to derive. I think this one's okay too. This one's okay too. Derive an expression for the average force, Vb, exerted on the projectile as it comes to rest in the block. Work is equal to the integral of f dx. We know, we're trying to find FB, we know the distance traveled is d. In the previous part, we solved for the work done, because that's the 1/2 JpVx, Yes, we're dropping the minus sign there because it's implied that we know that that force is acting in the opposite direction. Again, physicists are really bad with notation. And now I have 1/2 JPVX is equal to VBD. This is fine. We then solve for FB, the force of the block, and we get JPVX over 2D. That one is okay. I think that one's reasonable, okay? Now, this is going to get very unreasonable now, but we're going to work through it. Unfortunately, these next two parts are worth about 6 points. Getting 9 points on a free response is pretty okay, but we want to get as much as we can. Once again, now we have a problem where the projectile is going to fly into a block, and the block is going to move at the same time that the projectile is coming to rest into the block. It sounds very complicated. It's not, but the algebra sucks. So now what they ask us to do, derive an expression for dn, and dn represents the distance into the block for the projectile. How far does the projectile get into the block, okay? Once again, we have to start with a derivation. So we have to start with work is equal to change in kinetic energy. All the kinetic energy initial is going to go to 0. So we're going to solve for the work here. The kinetic energy initial is going to be balanced out by the work done by the block and the work done by friction. Two things are happening. The object is going into the block and coming to rest, but at the same time, the block is moving forward and it has friction with the table. So we have two sources of energy loss, the work done by the block and the work done by friction with the table. If you want, I would actually replace this with kinetic energy initial is equal to energy lost. I end up getting there by putting a minus sign on these two work equations right here, setting the whole thing equal to 0, and now I've got that the kinetic energy initial is equal to the work done by the block plus the work done by friction. The work done by the block is the force of the block times the distance that the projectile goes into the block, plus the force of friction between the table and the block and the distance that the block travels along the table. We're going to use this kinetic energy from the previous part, FB times D from before. We're going to substitute that in over here, and now I've got FBD is equal to FBDN. Again, I hate this problem because they're expecting you to keep track of D and DN representing the two different distances, and you're going to solve for DN here of FBD minus FTD over FB. Guys, please take a deep breath. If you can't figure out this part, don't worry about it. I really have a hard time with this problem. I really do. I don't know how many times I'm going to say it in the video, but I have a real hard time with this problem. Okay? Next part, derive, once again, an expression for dn, except now they want it in different terms. They want it in terms of d and the mass of the object and the mass of the block. So we can't just replace it with these two guys. Okay, fine, whatever. Let's use an inelastic collision. So I'm actually starting out with P final equals P initial. I'm going to make the correction here because I probably wouldn't have gotten points here unless I started out with P initial is equal to P final. If I didn't start out with that fundamental equation, I wouldn't have gotten the points because it says derive. Here I started substituting values in, I would have lost points. So I'm making a slight correction to my work right there. So mvx represents the momentum of the projectile. M plus big M represents the total mass of the projectile on the block times their new final velocity. All the kinetic energy that we have after the collision is going to be taken away by the force of the table, the force of friction with the distance traveled. So what I'm going to do here is in this part I'm going to solve for V by pulling over M plus M. And then I'm going to substitute this V right in here, and now I've got a whole mess of 1/2 M plus M times mvx over M plus M, the quantity squared, is equal to the force of the table times the distance that the block travels. We ain't done yet. This is going to get even worse. Now in the next part, I've manipulated it, so I've condensed it down a little bit, and I've got Ft times D, okay? Now I'm going to make this look like 1/2 mvx squared, okay? And we remind ourselves that this is the kinetic energy from the force of the block multiplied by the distance traveled, because we did that part from before. The force from the block onto the object is what's going to bring it to rest, okay? So now I'm going to replace this guy with the force of the block times the distance right here. Then I'm going to go even further back and remind myself from the previous part that the force of the block times the distance is equal to the force of the block times the distance into the object plus the force of the friction times d. And I'm going to solve for the force of friction times d by bringing this over to the other side, and I'm going to replace the whole thing. So I'm going to replace this FTD with all of this stuff, FBD minus FBdN. And now I solve for it, dN is equal to d minus d times m over m plus m. That's big M plus m. I don't give a crap if you couldn't get this. I don't think that's clear. I think that it is way too much algebra, and I just think this is a bad problem. However, the word derive is critical. If you see the word derive, you have to start with one of the equations on the equation sheet. And work is equal to change in kinetic energy is one of those equations. Please be super careful on that. If you see the word derive, start with a fundamental equation. That is the key thing to get from this problem.